Okay, so yeah, so let's just directly get started. So, um, so where I started my sort of approach for thinking was when we need to sort an array uh, of zeros, ones, and twos, right? So my way of thinking was inspired by insertion sort. I think like the idea just immediately came, but in hindsight maybe it was inspired by insertion sort. And like the idea was, let us just say that we have a long array, okay, some big array, and let's say that before this we have already done some sorting, so something like so 0 0 1 1 2 2, let's say this is what we have so far, and after this we have a bunch of other elements. So let us say something like there's a 0 here, there's a 1 here, or yeah, and then there's a 2 here, and then there's a 4, not a 4, and then there's another 1 here. Let's say this is the thing we have, and what I sort of like wanted, so this is what I wanted to do, this is what I wanted to achieve, is that with the algorithm what should happen is at every index, let's say some index I am at, so let's say this is index 5, then everything before here should be perfectly sorted. So which is the vibe of insertion sort, right? That like you will be at a current index and everything before that index should be fully sorted. So that's what I'm trying to demonstrate here. And like see, the thing is, by the time I get to 5, what should happen, how am I going to get it sorted until 5, I don't know. But I'm just going to start with the assumption that I am at some index and everything before that index is already sorted. The reason why I like started thinking this way, before this obviously I thought in a lot of different ways and I didn't know what to do, and like this way of thinking helped. And the reason, or like I don't know if you call it a reason, it's just starting this way helped me kind of figure out what are the things that are useful to track, like what variables do I need to look at. So yeah, so that's why I started off with this. So let's say I'm here, okay, so this is the index I am at, or I'll put an underscore. So this is the index I am at. Every index before this from 0 to like this is what, index 6, right? So from index 0 to index 5 everything is sorted, that's the assumption. So now this 0, so now this is the way, this is where we are starting, okay. Now how did this end up getting sorted, we will see later, like we'll figure out in a second. Okay, so let's say everything is already done. So oh yeah, and I'll start by explaining the basic algorithm that I created, and maybe I'll like run it and stuff, and then I made like better versions of it which I'll show in this other file. So yeah, okay, so fine, so let's just say we are at this index like I was saying, then and like I said, I'm saying this like 1,000 times, the assumption is everything before this is perfectly sorted, okay. So now this 0 must go to its correct position. How am I going to achieve that? So how we achieve that is by using swaps, which again is like what is this reminding me of? Maybe quicksort, insertion sort also is swapping, but like I read a bunch of these sorting algorithms and the swapping was a very big idea in that. So that's a nice idea. So essentially what you can do is do a 3 cycle, which those who solve Rubik's cubes might get excited when hearing 3 cycles, but yeah, I mean blindfolded Rubik's cube. I don't do blindfolded, but I've seen other people do it anyway. So the 0 is there, so you don't want to do a 3 cycle, right? So what I want to do is I will swap this 0 with this 1. So essentially what will happen is after that swap, this will become a 0, so the 0 is in the correct spot, but you will get a 1 here which is wrong. So then in order to make this 1 correct, you swap it with this 2. So this becomes a 1, this becomes a 2. So essentially what are the index values that we need to know? We need to know what the first occurrence of 1 is. We need to know where the first occurrence of 1 is, and we need to know where the first occurrence of 2 is. So let me just like write this in a function. So let's just call this, what did I call this? I call this 1 pass, I don't know, I think I call this 1 pass optimal or something. But anyway, that doesn't matter. Let me also include vector. I mean, my algorithm doesn't need it to be a vector, I guess. It's just if you use a vector, you can quickly do a swap without having to make temporary variables and stuff. So std vector int and let's call it array. Like I used to not call it ARR, I used to call it vec, but then in the previous like thing I called it ARR so much I got used to it. So anyway, so what I'm saying is you run your loop, right, and what you need to keep track of is you need one like pointer to keep track of the earliest occurrence of 1 and similarly for the earliest occurrence of 2. So that is essentially this index and that index. Then as you iterate through your loop, so there will be some loop, right? So let's just say for int I, I'm just initializing these values randomly, and then let's say maybe int n is equal to array dot size. So then this will be less than n and then I plus plus. So let us just say this is our thing. Then if what I encounter, if array at I turns out to be a 0, then what I need to do is I need to swap 0 like the current index with the earliest one. So std swap swap ARR at the current index with array at earliest one. After that I have to perform another swap, right, which is swap the array at earliest 1 with array at earliest 2. So I have to perform these two swaps. So after this, let me just like neaten up this thing. So eraser is here. So remove all of this, all of that. So a 0 came here, and then I think a 1 came here and then a 2 came here. So this is where there used to be a 1 and this is where the 1 is now. So basically what I'm trying to say is earliest 1 got incremented by 1 plus 1. So that is like now the earliest occurrence of 1. And the same thing for 2, right? There used to be a 2 here, the 2 is now here. So earliest of 2 also got incremented. So this is what you have to do when you are going through this list and then you see a 0. Now let's say you're going through the list and then you see a 1. If you're seeing a 1, then it's very simple. You just need to swap that 1 with this 2, right? Like with the earliest 2. So let's have that here. So else if array at I is 2, then what you have to do is do an std swap of array at I with array at earliest 2, and then what index has changed. Earliest 2 will get incremented by 1. What about earliest 1? That doesn't change, right? This is still the same, so that doesn't happen. Next, what if, so now let me see. So this one and this one got swapped. So now we have a 1 here and then we have a 2 here. So then this is the next index we go to. Here we see a 2, and if you see a 2, you don't have to do anything. It's just good. It's in the correct place. So that's basically the base like algorithm that I kind of came across, like invented, I guess, or discovered, is that you track where your earliest 1 is and then your earliest 2 is, and then once you have done that, everything after that you can easily sort by using these like swapping things, right? But then like the problem that comes is how do you initialize earliest 1 and earliest 2? Because here when we did all of these swappings, we like assume that everything before I, like I initialized I at 0 here, but like ignore this for a second. Like imagine I is somewhere in the middle of your array, or in this case a vector. Then then we are just assuming that every index before I, the array is already sorted. That's like the assumption with which we wrote all of this, right? This like increment and everything. But then really we don't know the array, what the situation is, right? Like really we'll be starting I at 0, and like our array could be something like, let's say something like 0 0 1 2. Okay, that's kind of sorted. Let's say 2 1 0 1. It could be something like this. So when you take I here, what is the earliest one that you take? Like, would you take your earliest 1 marker as this and earliest 2 marker as this, and then you start going from here? Well, no, because that breaks our like assumption, right? That everything before this index must be sorted. So you kind of need to have some way of figuring that out. Like as you start from 0, you have to make sure that you mark your earliest index markers, like you figure out where they are, and then at the same time you also have to sort it as you go. And then the moment you have an earliest one and an earliest two, you just need to do this, and then you'll be done, right? So that's the situation I was at this point. So what I'm going to do is, what I did was, I just created a dummy array. So let's just say I create like not a dummy array, but let me explain what I mean. So let's call this ARR, and then I just initialize this to be 0, 1, 2. Okay, like this has your starting thing, and then just put like random things. So let's say 2, 1, 0, 0, 2, 1, 1, 2, 0, something like this. And then what I did was, I ran my one pass optimal on array, and then I like to have this other function print vec, or in this case print vec. So that will take in a vector of integers, and which we will call vec. And then what this is just light, I mean this is nothing, vec dot size I plus plus array r. Like it's late in the day and my typing skills are horrible. Anyway, so std cout vec at I, and then we will just put a comma, and then std cout std end line. I know technically you can put that break line character, but yeah, like this is the end of a function. I just want to like do end line. There's some clearing buffer and all. I'm not that advanced. I don't know what that is. Okay. Anyway, so do this, and then we'll say print vec ARR. So yeah, now what I did was, I initialized the earliest one values. Like I just told it what those values were. So here is where we stopped, right? So earliest one is at index 1, and then earliest 2 is at index 2. So basically here, right, till here, this is the first occurrence of 1, and this is the first occurrence of 2. And then I just started my loop at index 3. So do you see what I'm doing? I'm essentially simulating this situation where you start at index 3, and then everything before index 3 is sorted. So I created an array like that, and I'm initializing the values like that. So this is array at 3, right? 0, 1, 2, exactly. And then everything before that is sorted, very good. And earliest one is 1, like that's where 1 is occurring for the first time, and this is where 2 is occurring for the first time. Yeah. So now this should hopefully like give us the correct thing. So let me go to the terminal here and run this. Yeah, no, this didn't work. This just like totally muffed it up. What did I do wrong? Let me see. Oh, sorry, that should be a 1. That should not be a 2. I don't know if it compiled correctly. I'll just do that again. And yeah, now it should hopefully work. Please save my sanity. What is going on? Why is it not working? I mean, it gave a different result this time, but it's still not working. Let's just like run through it. If you see a 2, then nothing happens. If you see a 1, you swap with the earliest 2. So it swaps with this, and then it's now sorted. And then you go here, and then it sees a 0. So if it sees a 0, I have a feeling I made something wrong with this. Was that correct? Array at I, swap it with the earliest 1. This should be I. Because the 1 is now at I, right? Yeah. So, and is everything else okay? Yeah, I think everything else should be fine. So there we go. So this basically works, okay? But then the thing is, like, this steady state condition for all like the physics people and like I guess whoever makes circuits or whatever. something, bro. So the steady state thing is where you have all the things sorted before your index. Till then you're like in some transient state where you need to collect data and see. So how do we do that? So what I did was, you just start by initializing them at -1. So basically, if your earliest value is -1, it means you don't have a valid earliest value yet. So yeah, and then let's just start this at 0. Okay, so start it at 0 exactly. So now what you do is, when you see a 0, okay, when you see a 1, you do a check. If your earliest one is a -1, then you set earliest one to I. And similarly, we'll add an else check here. And this else is basically what? If it's 2. So you'll check if earliest 2 is -1, then earliest 2 is what? I. Okay, so, and then I like to like just chuck this in one line. This looks like neater. I mean, you could put this also in one line, I guess, but I don't want to do that. So yeah, so this kind of initializes your thing, right? Wait, let me see if there's a better way to explain this. I mean, this is pretty self-explanatory, but yeah, let me try and explain this in a different way. So now let us imagine that we are making our final algorithm. We've understood that if once we reach steady state, which is we reach an index, we know the earliest one, we know the earliest two, and everything before that index is sorted, like it is in the correct order, then this algorithm perfectly works, as we just like demonstrated with this test case. I mean, obviously one test case is not enough to like concretely decide, but trust me, it's probably correct. If it's wrong, then embarrassment. Okay, so yeah, so now let's just imagine that we are now like seeing the array with fresh eyes. We are starting at 0th index and we don't know what is going to come, what's happening, nothing. So we are starting for the first time. So let us just say, I'm not going to draw anything right now, so like just imagine. So imagine you have started your array and then you are just seeing 0, 0, 0, 0, 0, like you're seeing a bunch of zeros. Okay, and your earliest one is -1, your earliest two is also -1, meaning you haven't seen a 1 or a 2 yet, you are just seeing zeros. So in that case, what does it mean? So it means that it's already sorted. Like you don't have to like swap any, obviously, like you don't have to swap anything or anything. So if you're just seeing a bunch of zeros and your earliest one value and earliest two value is both -1, then you don't have to do anything. Okay, like the earliest one and earliest two being -1 is an indicator of not having seen a 1 or a 2 yet. Okay, and then let's say as you're seeing these zeros, you see a 1 for the first time. Then what do you have to do? Whatever we did here, right? And when you see a 1 for the first time after a bunch of zeros, it means that that one is in the correct spot, right? So you don't have to make any swaps yet. Okay, right. Yeah, exactly. So fine. Another thing which I just want to point out is, if you're like we just discussed, if you're just seeing a bunch of zeros for a very long time, you don't have to do anything. You just have to keep incrementing your array like index. You have to keep incrementing I. So seeing a bunch of zeros is equivalent to not seeing zeros at all. Like what I mean is, for our algorithm, this analyzing this case, and then let's say there's like 2, 1, 0, whatever, something, whatever, is just equivalent to analyzing this case from 2, 1, 0 onwards. Because if you see zeros, you're not going to do anything with the 0. You're just going to let it and increment your index. So let us just forget for a second that you've seen that may or may not be zeros. Let's just say you're starting here, like with a 1 or a 2. So yeah, let's just say that. Now, yeah, so let's say you see a 2 for the first time, like you're starting, you just have a bunch of zeros and then you're seeing 2, let's say. Then what do? You mark your earliest 2 as I, which is exactly what we did here. In this case, it's 0, but there might be like a bunch of zeros and stuff, right? So you just do that. Similarly, if you're seeing a 1 for the first time, if earliest of this is -1, then you set this to I. Now there is a thing that you have to keep in mind, which is this 1 would be in the correct place. Like if you're seeing 1 for the first time, that would be in the correct place only if you haven't already seen a 2. So what I mean by that is, let's say you have a case where it's like 0, 0, 0, and then you're seeing a 1 and then something, versus you're seeing 0, 0, but instead of the 0 there is a 2 and then you're seeing a 1. Okay, so what you would basically do is, in this case, let me use red for that, then you would start, you'll see, okay, 0, do nothing, go to the next index, next index, next index, then you go to the next index, you see a 1 for the first time, this 1 is in the correct spot. So why? Because you haven't seen a 2 before it. So this is in the correct spot, so you just mark that this is your earliest one and you're done. You don't have to do any swaps or anything, you can just continue going to your next index. Okay, yeah, then in this case, if you come here, you're seeing 0, 0, you see a 2 for the first time, and with this statement you mark that is your first 2, and note that, yeah, I'll talk about that in a second. So you mark this your first 2, and then you see your next one, right? So if you see this one, when there is also a 2, what do you have to do? You need to swap with that 2, right? You need to swap with that 2. Then only your thing will be in the correct order. And another thing to keep in mind is, if you swap with the 2, then your earliest 2 has increased. Yeah, your earliest 2 has changed, and your earliest 1 also has changed. So let us now write that. So now if earliest of 1 is -1, you have made it I. Now let's run a check. So if earliest of 2 is not equal to -1, is not equal to -1, then what do you have to do? Then what you need to basically do is, if earliest of 2 is not -1, that means you have seen a -2, that means you need to swap these two. So we need to do an std swap of what? Of ARR at earliest of 2, and with what? With ARR at I, right? So you need to swap these two fellows. So now let's just take this case. So you take your earliest 2, and the reason you have to take the earliest 2 and not I minus 1, wait, can you just take I minus 1? Oh yeah, obviously you can't, right? What if there were zeros or something? Could you just take I minus 1? Okay, for now let's stick with earliest of 2. We will see if we can switch to I minus 1. It just struck me. But like, yeah, you don't know what the algorithm is going to be at the end, so you forget about that. So yeah, so essentially you swap these two, right? You swap these two. So now what is your earliest 1? It is earliest 2. And what is your earliest 2 now? It is going to be the previous earliest 2 plus 1. Why am I saying plus 1 and not, why am I not setting it, like why am I saying earliest 2 increases by 1 and not that earliest 2 becomes earliest 1? The reason is because, like, we could have had a bunch of 2s essentially. Like we could have had 2, 2 and then 1. Then basically you're swapping this one with this 2, right? So if you're doing this swap, then your earliest 2 is now this, right? It's not this. So that's why I said that. So if earliest 2 is not equal to -1, then you swap those two, and then after swapping you will set earliest 1 to earliest 2, and then earliest 2 will get incremented by 1. Correct? Yeah, exactly. Yep. Perfect. Next, what do we need to do? Okay, then what is this? Okay, this is us swapping. Correct. We should do this only in this case, right? We should do this uh, like swapping with 2 only when we are initializing it. We should not do it every time we are seeing 1, right? Like that's what would happen if you leave this if statement out floating in the wild, then it would just keep doing the swap every time. Now what I'm thinking is this statement should, well, it can just be there, I guess, no problem. Yeah, let it just be there. I mean, you can just put it here also if you want, is what I'm saying. It doesn't matter where you put it, but yeah, I'll just leave it here. And if it is -1, then you will do all of this. Otherwise, else you can just do the normal swapping thing, I guess. No, this also you have to do in a conditional case only. You do this only if there is no earliest 2, right? If earliest 2 is not equal to -1, you go ahead and do this thing. So yeah, so let me just think. I know the logic is a bit convoluted. I will make this logic better in like the next version, okay? So it's been 26 minutes, my goodness. Okay, so right, so what was I doing? So when we see 1 for the first time, you set it to I, and then you check if you've already seen a 2, which is what this statement is doing. And if you have already seen a 2, then you swap I with that 2. Yep, I mean you swap 1 with that 2, and then you set the earliest one to that 2 index, and then you increment 2, correct? And then what is your else statement? Your else, so when will the else statement activate? If you have already seen a 1 at some point. If you have already seen a 1 at some point, and you haven't yet seen a 2, then chill. Like, you are chilling, there's no problem. But if you have seen a 2, then you do the swap. Is this right? Yeah, that's absolutely correct. Okay, now let us look at this 0. We didn't do anything with this 0. So now let's say after like all of, if you are just seeing zeros for the first time, then life is chill. And also we know this, right? If earliest 1 is not equal to -1 and earliest 2 is not equal to -1, then like you can just do the normal thing. Like that's your steady state condition, right? So yeah. Now we will check for other cases. Now let's say that you are seeing a 0 and there is only a 2. So what I mean by that is, else if earliest of 2 is not equal to -1. So like if this case failed, that means one of them is -1. I am just in this case taking earliest of 2 to be -1, to be not -1, meaning earliest of 1 is -1. So that means you have only seen a 0 and a 2 so far. So in that case, what you do is you just swap between the 0 and the 2. Yeah, so you do std swap between array at I and array at earliest 2, and then you will take earliest 2 and then increment it by 1. Then we will have another else case. No, this should also be an else if case, which is saying earliest of 1 is not equal to -1. Right? Yeah. So in that case, what do you have to do? That means you need to like do the same thing but swap with 1, right? So earliest 1, and then the last else case is when both are -1, like earliest 2 and earliest 1 are both -1, then you just don't do anything, you just chill. So yeah, I think this covers everything. I think this should be correct. Let's run this and check, I guess. Okay, it compiled, that's a good sign. Yes, so it works. Okay, that's a relief that it worked. Now I'm going to do a bit of cheating. So I got ChatGPT because I'm not good enough at CPP to do this yet. Like I have no idea what this long and shit is. But essentially, hey, what did I do? Yeah, essentially what this part of the code is it like brute forces from 0 to 13. It gives you all possible combinations of 0 to 0, 1, 2 vectors. So and then this function like just runs. And this function like checks if you get the correct answer for each of those cases. So essentially, like if it passes this, then the answer is correct. Like the function is correct essentially. It compiled. Oh, it failed. Shit. Oh my god. What is this? What is this? Input is 1 0, but it got 0 0. How is that even possible? Okay, I messed up some swap here. Let's just see. This swap is correct, we know that. Okay, so let us just like dry run this, right? So first, if you see a 1, what will happen? You will set earliest of 1. I mean, if I say, yeah, that's true. Earliest of 1 becomes 0. Earliest of 2 is not 0. So yeah, then you're just chilling. Fine. Else and all doesn't trigger. This doesn't trigger. So then, yeah, okay. So then you increment. So then you come to 0. After you come to 0, what's going to happen? You will come here. You will check this. Is earliest of 1 not equal to -1? Yes. But this is not. Oh, hey. Oh my god. Okay. Yeah, let's try now. Yeah, so okay, cool. So it passed like all the test cases. So that's a good thing. So that means basically this algorithm is working. Nice, big relief for me. Okay, so clearly this algorithm is nice, like the swapping whatever is good, but then this initial getting to the steady state case requires so many if checks and all. It's just a absolute pain, right? So I was thinking, how can we fix this? And that's when I got an interesting idea, which is like basically what is the problem? The problem is when we start the algorithm, there is no sorted portion behind that index. Like we don't have any sorted portion. If we had a sorted portion, then it is like the steady state case and we can do the normal algorithm. So the interesting idea arises that why don't we augment? So what I mean by that is that we create a function. So I'm going to call this void one pass augmented vector. Okay, and this is going to take std vector int. It's going to be a pass by reference array, and what I want to do in here is like augment whatever. Like this is going to be some vector, right? Like I don't know, some random vector. I'm going to augment that vector with a 1 2 in the start. Like it's okay if there's no 0, right? This like just 1 2 in your starting position is still considered a steady state by our algorithm. If you're not convinced, like either rewind the video or just work it out on paper. Yeah, you just need to have basically like what is your steady state, bro? Steady state is that you have an earliest 1 and an earliest 2. If you have those two values, then you're done basically. And so that's why you don't need to have that 0. So what we can essentially do is take array and then how do you insert? You insert at array.begin, insert a 2, and then insert at array.begin a 1. So essentially what I've done is no matter what vector they give or no matter what array they give, you add a 1 and a 2 at the start. Okay. So now once you have done that, now this is the big thing. Your int earliest 1 is already decided. Int earliest 1 is what? It is 0. And similarly int earliest 2 is what? It's 1. And then you can start your for loop at what? Index 2. Right? And then I less than n, I plus plus. Oh, n is not defined yet. Let me go ahead and define that. I think we are never using that again, right? So why should I create a variable? Array.size. Okay. And then what you do is you do like the normal this thing. So you check if array at I is 0, then you do this set of swaps like this thingy. So let's paste that here. Get that back. Get that back. Get that back. So you'll just do this, and then else if array at I is a 1, then what do you do? You will. What do you do if it's a 1? I'll just copy it from here. Like I'm running a bit out of time, so yeah, this is what you do. Earliest 2 plus plus. Yeah, so that's it. So this should just work. No. So yeah, that's it. So I'm just gonna pass this augmented vector thing here. Like, do you see what we have? Oh no, sorry, this is not done. We need to do one more thing, which is remove those elements. So you do, so like because we added an extra 1 and 2, we need to remove that 1 and 2 from our array. So array dot erase. What do you erase? You take array dot begin, and then you add earliest 1. So this just removes that 1. Then similarly array dot erase, array dot begin plus earliest 2 minus 1. Because you have removed that 1, so your earliest 2 will shift back by 1 index. So you remove this and now your array is done. So yeah, let me just check if any edge case, like if we put 0 length or 1 length. Yeah, we are always adding these two elements, so we'll be fine. Int I only is initialized at 2, right? So if your array size itself is 2, this condition will immediately become false and you will terminate the loop. Yeah, so I think this is fine. So let us check. Yeah, so this is fine. Yeah, cool. So hopefully you understood. So basically, do you see the power of this code? Like just by like augmenting your vector with these two things at the start, you defaulted to your steady state condition. Because you couldn't do that, only all of this ugly mess is there. But we just augmented it with 1 and 2, so that made that thing very nice. But then there's a problem with this, which is like these erase functions and all, and I think even insert also, it needs to shift the entire array, right? So these are all O of n operations in space. No, in time. They are O of n operations. But like it's an extra O of n. But here it is just one single loop. Like you don't do any of these extra shifts. So in terms of time complexity, this is worse than this. Like way worse. It's like 4 times as worse or 5 times as worse. It's still O of n, I guess, but the coefficient is a lot larger. So that's like a pretty disappointing thing. That it's kind of like this is one for loop, this is another for loop, this is the for loop, and then there's another for loop, and then there's another for loop. Very vaguely, I guess. I don't know exactly how the erase function works, but I think it's O of n. So that was a problem, right? So I was like, okay, I can't augment my vector. So, but I still like this idea that you force like your initial steady state with this 1 and 2, and then you can like easily continue from there onwards. So if you want to like think about it or whatever, take some time. So yeah, so what I ended up realizing was, instead of augmenting, you can just edit the vector. So let me tell you what I mean. So let us just say that, let's say that our vector is something, so something random. So let's say 2, 1, 0, 1, 2, 1, nothing. Okay. So this is our thing. Now the thing is, these two elements, if I just replace them with a 1 and 2, okay. By the way, these two are just randomly created. I am not switching them. Okay. Like this could even be 2, 0 or something. I don't care what is there in the first two positions. I will just replace it with 1 and 2. Like whatever is there in the first two spots, I will simply replace it with 1 and 2. And then whatever is there can continue being there. Okay. Then from here onwards, it is the steady state condition. So I will do whatever I did in this augmented vector case. I will just run the normal loop without worrying about any boundary like edge cases or whatever, because like I literally created steady state for me. So after this, I'll have a sorted array. So let's like write it, so it will be 0 1 1 1 2 2, right? So 0 triple 1 2, exactly. But in this, what we need to basically do is this 1 and this 2 are extra. I mean, I'm choosing to take this 1 and this 2 because I know their index spots. This is going to be earliest 1, this is going to be earliest 2. I know their index spots. These two shouldn't be there. Instead of these two, we should have these two. So you replace at the end. Now, how are we going to replace? So for that, I came up with another idea, which is, okay, so let us just take 2 and 0 as an example. So I have 2 and 0. Now what you do is, this 2 has to go here, wherever the earliest 2 is. And then this 0 has to go wherever the earliest 1 is. And let us say that we had 1 also. Then that one can go anywhere. It can go here also, it can go here also. Your array will still be in the correct sorted order. Like if 2 goes to earliest 1 spot, then your thing will be gone basically. Right? So, yeah. So this is the idea, that you save these two elements, 2 and 0, and then you check, if the first element is 2, you put it in this spot. And then if it's 0, then you put it here. If it's 1, then you put it wherever, whatever, something like that you could do. But I mean, that seems a bit ugly, right? Like a lot of if checks will be there and stuff. But I mean, it is just constant time, right? It doesn't depend on the size of your vector. It is always going to be the same thing. But anyway, it still doesn't seem very nice. Like I wanted a better idea. So what I decided was, let's just say that you took this 2 and 0, right? You take it in a sorted fashion, in the sense, you will take two variables. So I'm just going to call them low and high. So in this case, 2 will be high and 0 will be low. Okay. Int whatever, something. So now what you do is, you take low and you put, and let's just for a second say that both of them are not equal. Okay, low and high are not equal. If they're equal, we will deal with it separately. So if they are not equal, you will take low, and without even thinking, you can put low over here. Like you don't even need to think whether it is 1 or 0, it will just go here. And similarly, this without thinking you can put here, you will be fine, right? Like what I'm trying to say is, if low and high are not equal, you don't even need to think. You just put low over here and high over here, no matter what they are. So like if you're not convinced, what are all the possible cases? So 0 2 is 1, 0 1, 1 2, right? Are there any other cases? 1 with 0 you can have 1 2, yeah, so that's it. So these are the cases. So you can just see, like you don't even need to think. You can just put this low fellow at the earliest 1 index, the high fellow at the earliest 2 index, and your array will be sorted. Okay. Now what if both of them are equal? So let me switch to green. So what if both of them are equal? So then you can have 3 cases: 1 1, 0 0, 2 2, right? So let's take the case of 1 1 first. Let us just, so with 1 1, you can actually treat 1 1 as low high. Actually, think about it. I mean, you can treat 1 1, if you have equal and both of them are equal to 1, you can just treat it as if both of them are unequal. Like you can just put the low here and the high here, and you will get the sorted array. Like, right? So with 1 1, actually you can treat it as one of these cases, and you will be fine. Now if it is 0 0, let us say this becomes 0 and this becomes 0. So you just say you do the blind assignment, you do the 0 0. Now how do you fix this? The way you fix this is, you need to perform a swap between this was earliest 1, between earliest 1 plus 1, which is this element, which will be a 1. You need to swap it with earliest 2. You need to perform a swap over there, and when you perform that swap, you will be done. So this case we took care of. Now let's say it's 2 2. So let me erase this and let me erase this. So again, you just imagine you do a blind assignment. This becomes a 2 and this becomes a 2. Then what do you need to do now? This 2 is in the wrong spot. You need to swap this 2 with here. So you need to swap the elements at earliest 1 and earliest 2 minus 1. You have to perform a swap. So for that, let's now write that function now. Hopefully you understood this. So one pass edited vector which will take std vector array int, take it by reference, call it arr. Okay, now what I want to do is, if you remember, in order to assign this low and high, we wanted this to be sorted. So for that, what I'm going to say is, if array at, okay, before this I'm gonna directly be accessing this 0, 2 and all, right? So we need to do one thing. We need to make sure that array dot size is, if it is less than 2, then you can just happily return from this function, and like it'll just be sorted on its own, right? So it's fine. If it is 2 or larger, then we can do a check, which is if array at 0 is greater than array at 1, then do std swap array at 0, array at 1, right? And now your int low can simply be array at 0 and int high can be array at 1, and then you will have int earliest 1 which will now just be 0, int earliest 2 which will now just be 1, and then you can just do this exact same thing. You can just do the whole thing again. I forgot a semicolon. You can just do the whole thing again. Now we need to restore the thing, like we have to put back the correct elements. Now for that, if you remember, we need to know whether they were equal or not. So let's have another thing over here, which is going to be equal values. I'll initialize it to 0. Okay. Now let's have another else if here. If array at 0 equal to array at 1, and so where is and array at 0 is not 1. So do you remember, if it is 1, you can just treat it as if it was not equal. You don't need to like specially treat it. So that's why I'm taking both of them are equal and not equal to 1. Then I'm going to set equal values to 1. Okay. Now let's come down here, and now what I'll do is I will take ARR at earliest 1 and just set it to low, ARR at earliest 2 and just set it to high. Okay. So now this will be the correct array if equal values is 0, meaning the low and high were not equal. So what does that mean? If equal values equal to 0, then you can just return from this directly. Okay. If they are not, so that means equal values is 1, you now do a check. If low is 0 and then else, right? You don't have to check if it is 2, it will be 2. So now if low is 0, meaning you have this case, which means that you like just put 2 zeros here, like 1 0 here and 1 0 here. Remember, this is earliest 2, this is earliest 1. So what do you now need to do? You need to perform a swap. So, oh sorry, that's the wrong if statement. Std swap between what? Array at earliest 2 must swap with earliest plus 1. So earliest 2 must swap with array at earliest 1 plus 1, right? And then if it was 2 and 2, so let's say this is can be there. If it was 2 and 2, this also is not needed. I'll just erase these things. So it was 2 and 2. What do you need to do? You need to swap this 2 with earliest 2 minus 1. So std swap array at earliest 1 must be swapped with array at earliest 2 minus 1. And then you're done. And then you can just return. So this is the like new, I mean, is it anything shorter? Yeah, I guess it is slightly shorter than this. It is, I mean, it looks as long as the other code, but in terms of logic, it's much simpler, right? Here we needed to check all of these cases, and the thing is, think about the situation where, let's say, instead of just 0 1 2, you had to do 0 1 2 3. Then, oh my god, like, writing this logic would be too messed up. Like, it would be insane to write some logic like this. I mean, I guess approximately, like, if you're using n unique integers, like n factorial cases you have to think of prior to reaching steady state. Right, so yeah. Well, I mean, if you have 0 1 2 3 and all, then it would be better to use that that algorithm, the actual, like, Dutch national algorithm, that one. But yeah, I mean, I wrote all of this before I saw the Dutch national algorithm, so I was like trying to solve this question myself. So yeah, so now let's see if this answer works. But anyway, like, the point being, this logic is a lot cleaner than this logic. Like, this was so hard to think of, and right, I mean, I took a very long time. Oh my god, this is like a 1 hour video, and half an hour of that was me explaining one function, and I don't know if I even did that well. So yeah, and that's like, I think you would have understood that once we reach steady state, after that it's very simple to do the sorting. Like, to reach steady state, it's hard, and that's where this, like, convoluted stuff comes. So yeah, anyway, so I put one pass edited vector in there, and I'm just gonna run it now, and hopefully it works. It did not work, it failed. Let's see what the problem is. Did I do some type O? Flow is 0. If array at 0 is greater than array at 1, if array at 0, 1 and swap. Oh yeah, I think that logic is correct. What's the problem? This should work. I think something's wrong here. Let us just think. If both are zeros, then earliest of 2 must swap with earliest of 1 plus 1, correct? And then, yeah, this seems correct to me. If equal values is 0, we just return. Okay, for the want of time, I'm going to go to my old algorithm. Yeah. This one earliest of 2. That's exactly what I did. Yeah. I mean, it seems identical. It looks like I've typed out the same thing. Array at 1. Oh my god, I forgot to do that. I forgot to even set it. Oh my god. Yeah, I forgot to do that. Yeah. Oops, my bad. Hopefully now it works. Yeah, cool. Okay. So yeah, this was my, like, set of algorithms for this question. Yeah, cool. Bye.